Good day. Let's evaluate this integral. And I realize this is under integration by substitution, but there's something pretty simple you can do to this, and it's going to be a walk in the park. What I'll do is that I'll do long division, okay, to get started. And actually, let me give myself some room here for the x. We have a 0x there, plus 3. Okay? And if you need to review long division, you can check out our website, www.acemymathcourse.com. But you won't be under calculus, of course. So how do we do this again? I take the x squared divided by x, put it up top here. Then I take that x and multiply it by the binomial. So I get x squared, and I put it underneath here. So x times x squared. X times -1, negative x. And then I can subtract them. So these guys cancel out. X squared minus x squared is 0. 0x minus negative x is positive x. And why did I add a 0x here? Because we didn't have that element, right? Then I can bring down the 3. And right now I can just take the x divided by x, put a 1 here. Then I'll multiply that 1 by everything over there and put it underneath. So 1 times x is x. 1 times -1, -1. Subtract them. So 3 minus -1, I get positive 4. What does that mean? I can rewrite this fraction essentially as x plus 1 plus 4 over x minus 1. Don't forget the differential dx. And look at that. That's going to make it a lot easier for us now to evaluate the integral, won't it? Because I can make it, I can break it down like this. Look at that. And like that. Now the integral of x, that's just going to be x squared over x. Oh, whoops, I meant x squared over 2. Sorry about that. And the integral of 1 is just going to be x. And over here, I can bring the 4 out. So I can get a 4 and multiply by the ln of x minus 1. Because that's what we do when we have something underneath like that, correct? And, well, essentially here, technically, I would need to do substitution. And why is that? Because I can say x minus 1 equals u. So dx, the derivative of that is just 1, so I can just write dx equals du. Right? So then essentially I have 1 over u du. I can just replace the dx for du since they're the same in this case. And the integral of 1 over u is just the ln of u, of the absolute value of u. Okay? Now, then of course I can take that and replace it. So I get 4 times ln of x minus u, sorry, x minus 1. And keep making mistakes today. And that's what we had over here. So that is the final answer. Hopefully that made good sense. And we have tons of integral videos on our website right here. Good luck.